Assalamualaikum and good day, dear students. So now let's discuss roots of equations, bracketing methods. Now we look at force position method. Force position method is an improvement of the bisection methods. In what way? The bisection method converges slowly due to its behavior in redefine the size of interval that containing the root. So remember, when we discuss about bisection methods, the estimation of roots is calculated, okay, by using the midpoint formula. So we can say that the convergent process is quite slow, okay. So alternatively, we can improve the convergence of the roots estimation for bracketing methods by using force position methods. Alright. In Latin, okay, force position method also known as regular falsi methods. Okay, so now let's look at the process or procedure how to calculate our roots estimation using force position methods. The procedure begins by finding an initial interval, means that interval bounded by our lower limit and upper limit that bracket the roots. Okay, so we have the important point here. Force position methods also categorized under bracketing methods. Okay, so therefore we required two initial guesses in order to start the computation process, okay, which is SL and SU. And then force position method also always converge, okay, always converge to the true solution. Alright. Okay. FSL and FSU are then connected using a straight line. The estimated roots SR is the x value where the straight line crosses the x-axis. Figure C indicates the graphical illustration of force position methods. Okay, let me explain again based on this graphical illustration. Alright, so in force position methods, let's say this is our function, okay, let's say this is our functions that we want to estimate the roots, alright, where this is our aim, this is our true solution for this function. So to estimate these roots of this function, okay, so of course we must to decide our lower and upper limit, okay, lower and upper limit, and this lower and upper limit must bracket your roots. So how do we know? Okay, based on this condition, FSL multiply with FSU less than 0. Alright, and then after that, in order to calculate the SR in our first iteration, okay, so we connect these 2 points, FSL and FSU, with a straight line, okay. This is what's told by this point here. So if you connect FSL and FSU with straight line, then you can get the value of your SR, where the SR is actually where your straight line cross the x-axis here, okay. So at this point here. Okay, so in order to get the formula for SR given by the force position methods, so the idea is actually based on this triangle here. Okay, we will look later the formula for SR by using force position methods. Okay, and then after that, the algorithm similar with the bisection method in order to check whether our roots lie in lower subinterval or upper subinterval. Okay, now let's look at how we obtain the formula for force position methods. So straight line joining the 2 points SL, FSL and FSU, SU, FSU is given by, okay, so to give you an overview, so I have here okay, so from the previous slide, so look at this first iteration here. Then if you look here, by joining FSL and FSU with the straight line, okay, so our aim is to get the formula for this SR. So actually from here we can have two triangles, the smaller one here, okay, this one, and then the bigger one here, this one. So all this formula here actually come from this calculation of this slope here. Okay, so if I can share with you how we get the formula for force position methods. So from the bigger triangle here and the smaller triangle, we look that both share the same slope. Okay, so I can have here M1 equal to M2. Alright, so the calculation for M1 is also equal to FSU minus FSL divided with SU minus SL. And then the calculation of M2 is equal to FSU over SU minus SR. Okay, so if I rearrange this equation, I will get SU minus SR also equal to FSU times with SU minus SL divided with FSU minus FSL. Okay, so if I factorize the negative for denominator and also numerator and denominator for this part here, okay, so now I should have negative FSU times with SL minus SU over, right, negative FSL minus FSU. Okay, then I can simplify this negative here. Okay, negative I can cancel off here. Okay, so now what I have is SU minus SR is equal to FSU times with SL minus SU divided with FSL minus FSU. Okay, so since we only want the subject is our SR, so rearrange this equation equation here, okay, so I should get XR is equal to XU minus, okay, if I represent this whole thing here as star, so I can have here XU minus star here, okay. This is actually what I have here. So this is the force position formula. Okay, so this is our force position formula. Okay, it means that what we have here, Alright. Okay, now let's look at the algorithm. So basically the algorithm for force position method is similar with bisection methods. The different only at this formula, okay, formula on how we estimate the roots, okay, the estimation roots. Now we apply the force position formula. Okay, so step number 1, choose the lower gas XL and upper gas XU that bracket the roots such that the function has opposite sign on the interval x between x lower and x upper. And then second step, we calculate the estimation roots XR by using this force position formula. Alright. And then step number 3, we have 2 subinterval, okay, then we need to evaluate in order to define or to identify which subinterval that the roots lies. So we apply the test condition. If FSL multiplied with FSR less than 0, then the roots lies in the lower subinterval. Therefore, we set XU equal to SR and repeat step number 2. If FSL multiplied with FSR give us positive value or greater than 0, then the roots lies in the upper subinterval. Therefore, we set XL, new value for your lower, X equal to SR and repeat step number 2. If FSL multiplied with FSR equal to 0, then the root is equal to SR. Terminate the computation process. Then step number 4, calculate the approximate percent relative error by using the epsilon A formula. And then step number 5, we need to compare with the stopping criterion. If absolute percent relative error less than the prescribed tolerance, then stop the computation. Otherwise, we go to step number 2 and repeat the process by using the new interval. So basically, the algorithm for force position similar with bisection methods, but the different only on how we calculate our SR.